Welcome to the SBGrid YouTube channel. Software tutorials by developers, lectures by structural biologists, unique content brought to you by SBGrid.
Welcome again to everyone to this webinar series. Today we have with us our speaker, who is José Luis Vilas. It is a real pleasure for me to introduce him. Dr. Vilas is a staff scientist at the Centro Nacional de Biotecnología, CNB, in Madrid, which is part of the Spanish National Research Council. And his research focuses on computational methods for structural biology, with a particular emphasis on cryo-electron microscopy, single particle, and tomography. He has played a key role in the development of new single particle analysis methods for measuring local resolution and quality analysis of cryo-EM reconstruction during his Ph.D. Then he carried out a postdoctoral stay at Yale University under the supervision of Professor Hemant Tagare, where he worked on problems of anisotropy in reconstruction and the quality analysis of the cryo-EM reconstructions. Currently, he leads the Scipion tomography framework development, driving efforts to integrate, standardize, and streamline tomography workflows. His work bridges software engineering and structural biology, enabling researchers to process increasingly complex datasets in a more efficient and reproducible way. And on a personal note, I had the pleasure of working with José Luis at the CNB, so it's especially nice for me to welcome him here and introduce him to you today. In this webinar, he will present the latest advances in Scipion for tomography, and he will share the recent development that are shaping the field. So any questions you have, feel free to put it in the chat, in the questions and answers. And then, José Luis, thank you for being here. And whenever you are ready, the floor is yours.
Well, thank you for extending the invitation. Just to double check, can you see my screen?
Yes.
Okay, good. So, as Estrella said, I'm José Luis Vilas from the Spanish Research Council, and I lead the tomography developments in the lab, and particularly with this software that we are developing that is Scipion for tomography. And during this talk, I will address this topic. So first, I will give a short introduction to cryo-electron tomography, which is a topic that we already know probably. Then I will introduce Scipion for tomography. We will carry out a live demonstration of this software. And finally, we will finish with some capabilities and results of the software. So that said, there are two main techniques that are single particle and cryo-electron tomography. And I like to see this difference between them. So in single particle, we have a sample that is purified, and the images contains multiple views of identical objects, but multiple view from multiple point of view. But in contrast, in cryo-ET, what we have is richer information, because perhaps we are observing part of the cell in its native state, but we have another limitation in which we have the same sample, but from different point of views. So it implies a limitation, but also with richer information. So the number of entries that we observe in NDB is that tomography is growing in the last years. So the red curve is telling us how many maps have been deposited in EMDB in the last year, and the black line is telling the same for tomography. So we observe that the single particle has suffer an exponential growing behavior, but if we take logarithms, we see that the behavior is exactly the same. So I believe that tomography will present this growing during the next years. So the workflow is simple. So we introduce the sample in the microscope and we tilt the sample, acquiring many images, one image per tilt, but we have to limit the dose because we are acquiring, instead of just a single image, we acquire many images. And due to this rotation that we the tilting process, some misalignment can occur. So that implies that we have to correct this misalignment in order to have to explain all images as a single axis rotation. So once we have aligned the estimated these alignment parameters, we have a single angle rotation, and we can continue with the tomogram reconstruction, in which we need to find a 3D structure that explains all images as projections from different point of views. So once we have this, we can start with subtomoral averaging, in which we target a specific protein, a specific complex inside the cell or inside the tomograms, and we identify it in the images, and then we have to align the images in order to have a high resolution structure or as much quality structure as we can. So this is the subtomoral averaging. So to do this, we have some images that are quite noisy because of the difference of densities between the solvent or the ice thickness, because in the cell we do not have solvent. It's just the ice and the atoms that compose the proteins. So we want to reconstruct this 3D structure from these noisy images. But before continue, what I'm going to do is I want to execute something, and we will come back later. So I'm going to open, this is the Scipion, the software that we develop, and what I'm going to do is to execute this workflow, and after a few minutes we will come back to it. So it's just a cell, a lamella acquisition from a Chlamydomonas that now should be starting, and we will come back later to this. So this is the image processing that I was talking about. So, but if we are going to do image processing, now the question is what software we want to use. So there is a huge ecosystem of software. So we have Relion, we have iMod, we have eEnclarity. Some software have good points, or could be more complex, but other works with some formats different than the others, and we have to make a decision. That decision is which one. So let's imagine that we have two softwares that I call A and B, and they can be complementary. So one is extremely fast, the other is not as fast as the other one. One is very reliable, the other is not very reliable, but in contrast is very user-friendly. So there are good points and pros and cons that we have to take into account in order to decide which one to use. So this could be in terms of performance, but there are other variables, like could be picking. So one is good at picking and other is good at classification, but the opposite, one is bad at picking and the other is bad at classification. So we have to make a decision. And to address this problem is why Okay. Why is not? Okay. This is why we created Scipion. Scipion was published in 2022, at least the branch of tomography. And it's a software that is thought for biologists, developers, and facilities. So we cover these three target users. And the idea of Scipion is that you don't have to choose a specific software package. You can process with all of them at the same time. So Scipion is a graphical interface in which it adds all this software ecosystem and the user choose which one is the most suitable for a specific task. So to carry out what Scipion has is an standard behind. So all data formats are converted into the Scipion format, and from the Scipion format to the specific software that will be used for a specific task. So in this regard, it's safe because the user do not have to make a data format conversion, which is always prone to errors. And on that, we add visualization tools that are the original visualization tools like 3D Mode or eMan or the viewer of Dynamo. So you can continue using not only the software that you used to use, but also the viewers that are more familiar for you. So since the beginning in 2022, we learned a lot, and now what we have is a 2.0 version in which is a much more mature version of ScipionTomo, and we were focused on reliability and stability. So that is our main goal and was our main goal during the last year since it was released. And probably this summer we will release an unstable version because never was announced, but now we would like to announce an unstable version. So this is the ecosystem of software that you can find in Scipion. So as you can observe, there is a lot of software. So you have software for movie alignment from XMIP, Motion Core, or Warp, or for CTF estimation, you have a lot of estimators, and same with picking and tomography reconstruction. So this is a huge ecosystem of software, so the user can choose the most suitable for a specific task. So this question is obvious. So okay, I chose a specific question, a specific software, but now the question is, I got a result, and can I trust in this result? And so is the estimation that I carried out correct? And for instance, this is an example. This is a real example. So we know that the defocus was 2.7, and the software obtained 2.7. But what if we did not write the target defocus or the nominal defocus that we obtained during the acquisition? So then, in that case, we cannot sure if the CTF estimation was correct or not. So why I need this huge ecosystem of software? So, well, something that we can do is, instead of using a single algorithm, we can use many algorithms. So for instance, let's estimate the defocus with one software, the software A. So this is an experimental case. So what I'm showing here is an experimental case. So the software obtained 2.7, except for one view that is around 27 degrees, for instance. I'm not sure. But we execute the same experiment with the software B and the software C. And the software B is more or less in agreement, providing the same CTF estimation, but the software C is completely different. So if I could use software C the focus estimation would be completely wrong. But if I have multiple software, I can validate the estimation of parameters that I have. And one software does not fit all datasets, so it's always good to have redundancy in the algorithms in order to estimate the parameters. So okay, so this is how we can process. So there are two different manners of carry out the image processing in Scipion. One is the standard processing, in which I have a workflow and I have a data set and I execute step by step the algorithms behind. So for instance, I have movies. So the first step is the movie alignment. So next step should be CTF estimation. So once I carry out the motion correction, I can carry out the CTF estimation. Once the CTF estimation finishes, what I'm going to do is to carry out the till series alignment and so on with the tumoral reconstruction and later with peaking and subtumoral averaging. But this is the standard processing in which one protocol or one step is executed after the other. So this is how generally we process. The other processing is leaf processing or in-streaming, in which imagine that I measure 100 holes in the microscope. Then, as soon as I get the first hole acquired, then I start processing the first movie. As soon as the first movie finishes, I start aligning the till series. And as soon as I finish the first till series, then I reconstruct the tomograms. But if I already measure 50 holes, probably I will process 50 movies. But once my 50 movies are aligned, I already process 49 till series because there is one remaining till series that is still processing, and so on with 49 or 48 tomograms reconstructed. So this is the demonstration that I was executing here. So what you are observing here is an acquisition in which I have acquired 75 movies. Motion Core is processing these 75 movies and already has obtained 42 micrographs. So 42 movies has been already aligned. And now this is a kind of base acquisition because its till series is composed by 41 images. Then I already compose my first till series. And I can observe this till series. Just I can do right click and open this till series with the Tomo viewer. So this is the till series that I have. This is my lamella, and these are the views that I have in the till series. You can see how they oscillate a little bit because it's not aligned, but it's just the till series that I already acquire. So next step is, well, it's not mandatory, but it's the X-ray eraser. The X-ray eraser removes bright points or pixels that are out of range. So I had two till series that are coming from the compose, and two till series are already, the X-rays are already removed. And once I have that, I start with Aretomo. You see how the input are two till series, And RTOMO already aligned one till series, so it is still aligning another one, and we can observe the tomogram that RTOMO already reconstruct. So here we can see the tomogram with RTOMO that is a cellular environment of these chlamydomonas, and we can see how, well, perhaps it's not the best tomogram of the world, but it's quite good. It's quite good. So this is the viewer that we have, so we can increase the contrast, so we have some nice features to do these kind of things of the visualization. And we can open it with iMod if we want. Perhaps with 3D mode is more convenient, it's more close to us, so we can observe the same tomogram with 3D mode as usual. So the fiducials are more or less symmetric, so it's relatively well aligned. So all of this works in an automatic. But as you know, RTOMO does not provide the CTF correction, or at least the version 2. This demonstration is with the version 2. The version 3 is now, we are about to release it. So RTOMO process 1 till series, and now we have performed a CTF correction, a local CTF correction for the first till series with iMod. So we are combining RTOMO with iMod and previously with motion core. So we correct the CTF, and later we can reduce the size and perform a tomogram reconstruction that we can choose if we want with iMod or with 3D mode. In this case, for instance, with 3D mode, we can see, thanks to a shared algorithm, how the contrast is enhanced a little bit, and we get the tomogram reconstructed in real time. So this is a solution for the facilities in which as soon as you acquire the data, Scipion is providing you feedback and results in real time during the acquisition time. So this is working, and in fact is working in 3 facilities. So we have here another workflow in which involve an HIV sample that I'm going to execute, just to do the same, and we will come back later to see the result. Okay. Did I execute? Yes. And in a remote machine, is slightly slow. Okay, so for the leaf processing, this is the pipeline and the algorithms that we have. So we can align till series, estimate the CTF, and tomogram reconstruction and denoising with all these algorithms. All of them in streaming except ISONET. So that is a typo. And as more or less you could see, so Scipion is just a graphical interface. So we do not modify the original software. It's just a graphical interface in which makes your image processing simple. Instead of executing a command line, you have a graphical interface with the same parameters and exactly the same entries that your original interface. If you open Relion and you open Scipion, you are using exactly the same version of Relion and the same parameters of Relion. So it's nothing different. It's just what it changes is the graphical interface. And the philosophy that we have to integrate things in Scipion is we preserve the names and the units of the original software. So what you see in the forms should be what you see in the forms of the original software. The added value that we have is this traceability. So in the right, you can see a tree in which there is very different software working together. And connected in a very simple manner. So as well as this, we have viewers. Oh, sorry, because the PowerPoint is slightly slow. So we have viewers from iMod, like 3D Mod. You can open your tomograms or your coordinates with Iman. So whatever you normally use is still in Scipion. And we were really focused also in the users. The idea is to make the image processing simple. One of the main problems of tomography is that it's very manual. So it's true that the live image processing will help you a lot, in particular for facilities. But at the end, if you want to extract a lot of information from your data, you have to curate your data sets manually. So that option is also available. So all objects that you can find in tomography has been models, like the object in, for instance, in this case, tilt series. So a tilt series, what has? It has tilt image. So in this case, we have a tilt series, as you can see in the center, that is composed by 40 tilt images. The images has a size and a sampling rate. So that information is written there. And then we added some flags. For instance, we added the flag interp to show that the tilt series has been interpolated, align it, and with the alignment apply. We added a flag that that tilt series has the CTF corrected. So this added information simplifies the image processing. And the other thing is, okay, perhaps there are some views that are not correct, so we don't want to use them. So with the viewer, I can mark, you see that square box in which you can mark the views that you don't like it because perhaps are dark images, they present contaminants, they present a huge shift, or the eyes is not good. So you can mark them and then will not be used in your image processing. And this information is preserved in the next steps. So they appear as marked as not used, but you know always what you remove from the beginning. Similarly happens with the CTFs. If you have CTFs that are out of range or that presents a poor cross-correlation value or a poor estimated resolution, you can remove them and those the focus will not be used. In the moment in which, for instance, for a subtomal averaging in Relion or for a CTF correction of the TIL series that converts a TIL series and a CTF, then the intersection of both sets is taken. So only will survive those tilt images which has a CTF enabled. So you can identify and remove tilts because of the CTF or because they are bad used. And the other thing, we were really focused, as I said at the beginning, in reliability and make it everything robust. So what happened if the user introduce values that does not make sense? For instance, what happened if we try to consider in Aretomo more voxels for aligning than the actual thickness of the tomogram? Then we raise a warning. We have a validation saying, hey, you, the user, are introducing some values that are not, does not make sense. So this value should be smaller than this one. And this prevents of errors, because otherwise the command line that you execute in your terminal will be executed, but will fail. In this case, we are preventing from the failure because of these validations. Okay, and what about subtumor averaging? In subtumor averaging, we have a lot of pickers. So pickers is one of the main, in my opinion, main bottlenecks in tomography right now. So we have the template matching of Iman, the dynamo geometrical based picker, DeepFinder with deep learning, PySec for membrane proteins, another template matching of Capstop, which performs extremely well, or Cryolo from Sphere. For aligning, you can align your tomograms with Eman, the full pipeline, Dynamo, or Relion. And for the geotinity, that means classification, well, Eman, Dynamo, Relion, or PySec. So about the results that we can get with this, what we obtain is what it is reported in the literature. So if you go to these data sets and you see the resolution, then we were able to obtain the same resolution than the original publication. So with these data sets and other ones that belongs to users that we have here that have been used ScipionTomo for their image processing, but there's no previous reported resolution. Okay, so let's see how it goes, the image processing that we execute. So in this case, I'm going to stop the streaming of the previous acquisition. And this other was the HIV, the most common sample probably that everybody is doing tutorials with this sample. So in this case, we took another 2 TIL series. In this case, this TIL series present fiducials. So here you can see the HIV virus with the fiducials. And instead of aligning with Aratomo, we align with IMOD, with the fiducial base alignment. And it's still running, but it aligned the first TIL series. And we can open this, well, in fact, it aligned 2 TIL series. And here we can see the TIL series with these views, and more or less you can see how everything is well aligned. We can open it with 3D mode if you want. So more or less, so the aligning is quite good. So everything rotates in a smooth manner. So what I'm showing here are 2 different workflows, one for fiducial sample and the other for fiducial sample. That one involves more steps than the other, but so we have workflows for both kind of samples. And what is running here is feeder, because as you know, the fiducials can introduce artifacts that later complicates the picking, and more later in the next steps the subtumor averaging. So we have feeder to remove the fiducials and perform finally a tumoral reconstruction. So, but the thing is that the workflow is is running. So let me continue about what we have observed with Scipion and, well, not with Scipion, with tomography in general, is that there is an increasing demand of courses, an increasing demand of tomography. And a proof of that is that last year we had 5 courses, and this year we have 4. In fact, there is another one in Salamanca that is scheduled also in June that I didn't read here. But the demand is increasing. So this pipeline for facilities is implemented in 3 facilities. Like it's CSSB in Hamburg, DCI Dutzet Center in Lausanne in Switzerland, and in the CMB here in Madrid. And there's another couple of facilities that are under evaluation that because they are not using it, so I didn't write it explicitly here. So this is more or less the capabilities of ScipionTomo. So as conclusions, ScipionTomo provides the full workflow from movies to averages. So that means from TIL series movies to reconstruction of proteins. So from movies to subtomal averaging. So the pre-processing from movies to tomograms, even denoising, is extremely fast. So you have leaf image processing in an automatic manner. So it's true that if you want to extract all as much information as possible, you have to curate manually the data sets. But despite that, you will have some feedback about your acquisition with this leaf image processing tool. And something that I like to insist is that Scipion does not modify the original software. It is the original software, but it adds a layer that is an integrative layer with a nice interface and forms to visualization tools to make your image processing more simple. Finally, I would like to comment that here in the CMB in Madrid, we have a service. We belong to Instrat, Instrateric, that is a service of structural biology research infrastructures. And if you have a data set that could belong to single particle, flexibility in single particle, or specifically now in tomography, we started recently to accept electron tomography projects, and we provide, I think it's 15 days of image processing for free for your sample. So you have to write a short project to Instrat, but if the project is accepted, we provide the image processing as a service for free. So feel you free to contact us in that regard. And before finishing and say thank you, I would like to come back here, see the project, and feeder takes time. So it's still running, but feeder takes time. And meanwhile, what I come to show you is a full project. So this is the original Chlamydomonas, this cellular environment sample. But what I want to show you here is how it is possible to go from movies in a complete automatic manner, doing even adenoising with cryocare, which provide really nice tomograms. You can see how the contrast it's enhanced a lot. So in this data set, we wanted to obtain averages of this ribosome. And well, the contrast was enhanced a lot with this denoiser. And as you can see, it's a cellular environment. And what we did is we use M and Tomo as template matching, and we refined with Relion to obtain an average, which we stopped at being 2 because this was a tutorial, but we were able to obtain the ribosome, which is not the best ribosome because it's in this case a tutorial, but with only 2 TIL series it's possible to have the reconstruction and visualizing the results in Chimera. Okay, and this is all from our side. So just say thank you to SBGrid for the opportunity of this talk. If you would like to use Scipion, you can install it through SBGrid, and we used to offer the installation and the full support for the facilities. So if you are a facility and you are interested in try this leaf image processing, you can contact us and we will help you with the queue system and all the setting that you need. So this is the lab. In particularly, I highlighted the people who has especially contributed to this pipeline. And also, if you want to contact, we have a Discord channel in which is relatively active, and you have support in less than a day generally. So thank you so much. I can take questions.
Thank you very much, José Luis. I don't know if there is any question. I don't see any question on the chat right now, but feel free to write there, or not sure if you can unmute yourself and directly ask the question, but maybe
If
we can
if you want to unmute yourself, please use the little raise hand thing, and we should be able to unmute you. And we also have the Q&A option if anybody would like to drop questions there.
Yeah, I think I cannot see the Q&A, or I don't know how.
I've got the Q&A
Well,
open and there's nothing there.
okay, okay, perfect.
And I
So,
also see no questions in chat.
okay, so take your time to write the questions or raise your hand to mute yourself. In the meanwhile, thank you very much for the Scipion tomography. What can I say? I already know it, and I think it's awesome because it's really allows you to do the full pipeline without the scripting, without the need of transforming and translating the data from one software to another. So I saw that you said that there are 3 facilities already using it. Do you have already any feedback from them?
For now, what I know is that they are quite happy. We have a close follow-up, and what we would like is that if you are a facility and you use it, is to send that feedback as they are doing. Because in that regard, we can have in mind what are your needs in order to address them.
And of course, this is for facilities, but Of course, Scipion is also for individual users, for labs. And they can also use the streaming file part, even though they have already the whole till series, but I just wanted to clarify that. And also you mentioned that probably you will do a new release by summer. So what are the next steps for Stipion tomography or the news we can expect?
Probably the news will be an automatic tilt bad views. We would like to remove automatically bad views based on some criteria. Also, the reliability will be increased, especially in the leaf image processing. So last months we were growing a lot in leaf image processing. Probably RTOMO 3 will also be released, and Picciolo also will be released. That is a picker. And as well as some denoisers. We have some denoisers right now, but I cannot tell you which one will be released. But at least could be Isonet or ice cream. But
Great.
that depending on we don't want to release software that is not stable enough. So that is the philosophy that we are following right now. So that will depends on, not because the software is not stable enough, it's because we want to guarantee that in Scipion is stable enough.
Sure. And now we have some questions in the Q&A. So if someone wants to unmute, if not, I can read them. The first one is, which version of the TIFF software is used via ScipionTomo, and what happens when the software are updated?
Can I see the questions?
Yeah, I think in the more option, you have the Q&A.
Oh, okay. Which version? So that depends on the plugin. So I can tell you that Rulion is Rulion 5. We are now updating for Rulion 5.1. Eman is 2.99, but that is the latest version. iMod is iMod 5, but I cannot tell you the next digits, but most of them are the last version. So RTOMO 3 is the one that we want to update right now. That is perhaps one step behind because we are with RTOMO 2. We maintain the software, so we announce the updates every time that we update a plugin. You can update it. That happens every, I don't know, a few months. This year it took several months, but it was a big step forward. But generally, we update minor changes every few months. So, what is the minimum computational requirement to start with the tutorial? I would say 32 gigabytes of RAM, and with 1 terabyte should be enough, and a GPU. Where can we find about the upcoming workshops? So the upcoming workshops generally traditionally we have a workshop in Spain, in Madrid, that is announced in the Instrat webpage that perhaps you can paste here. So that is the traditional workshop that we have, but the others generally are organized perhaps for a congress or a specific institution that ask for a tutorial or a course, and we go to that place to offer the course. So if you're interested in a ScipionTomo course, we will be open to go to your institution and do the course. Could M-Warp be included at some moment? Warp is in the pre-processing. In the pre-processing for the motion correction. And M reality is that we have a beta version that is integrated, but we want to guarantee that it will work in a robust manner before releasing it. It has been tested for a long time, but we are not still fully happy with the reliability of the M software in Scipion. So, but it will be there. It will be. I cannot tell you when, but it will be there.
And Duncan has his hand up, and I think he is now unmuted.
Yes, can you hear me?
Yep.
Yeah.
So I had a Tomo question, which you may or may not be able to answer, and it may be a dumb question, but I've always wondered why the thickness needs to be defined for the tomogram itself. So let's say you have a slab that's 100 nanometers thick, and you take a tomogram of it. But in theory, you could have something else where you've got some piece of junk, sitting on top. You want to have that tomogram include that piece of junk on top because maybe it's important for some reason. Why is it important to define the thickness to a certain thickness and not just have it fall out as vacuum versus ice slab?
It's not a problem. If you provide a larger or a greater thickness than the actual ice thickness, you will see the in the tomogram the ice, the slab of ice in the reconstructed tomogram. What other software like Aretomo are asking is the tomogram thickness, that it means how many pixels will your tomogram will present.
Right.
But inside that thickness, you will see the ice layer that is your real reconstruction
sample.
of the sample. And also, Aretomo, what it has is the alignment thickness that is inside the tomogram. What is the thickness that will be used for aligning the TIL series? So I don't know if your question was related with this second parameter, but so if your tomogram is 100 pixels, perhaps Aretomo only align 50 pixels.
Right.
So the center of the tomogram will be the pixels that will be used for aligning the TIL series, because Aretomo works in an iterative manner. So aligns and reconstruct, projects and compare the images with the projection.
Right.
But it will only project the center of the reconstruction.
Okay. No, I was asking because in past and in future, I'm going to have some non-uniform samples that's going to have vacuum sort of interspersed. And I was wondering if there was a technical problem with that, generally speaking, because I have seen these warnings come up of like, make sure the thickness is correct. I was like, well,
no.
Okay.
In that case, was for Aretomo, for aligning, not for the tomogram thickness itself.
Okay, great. All right, thanks.
So you
That's very
cannot
helpful.
align. Let's say that you cannot align more pixels than the size of your tomogram.
Sure. Yeah. That makes sense. Okay, thanks so much.
And the last question is semi-service and semi-collaboration implementation available? I'm not sure what you mean. So if you mean with Instrat, Instrat is just a service that could be a collaboration, but in principle, Instrat works as a service. But if the group would like to convert that project into a collaboration, could be a collaboration too. Not sure if the question was in that regard.
Yeah, I don't know. I don't know also if that was the question, but if anyone wants to mute and ask the question directly or clarify. Okay. And also if you have any other questions, I don't see any other question in the chat or questions and answers.
Yep,
Or
I don't
any
see
other
any new questions in the chat either.
Okay. I had pasted on the chat, hopefully you can see it, some links, the instruct where the training is announced. Also the link for the tomography tutorials in Scipion, and also a link to our SBGrid software support software webpage, because of course we have a Scipion already integrated in SBGrid, and it has almost all the plugins for single particles and for tomography. They have been updated very recently, just when from Scipion developer team they released it, we updated them, so it should be available for you right now. And so please, if you are using or you want to use Scipion tomography inside SBGrid, feel free to contact if anything is not working properly. As you may imagine, we have a close collaboration with Jose Luis and his team, so we can fix anything that is not working for you as soon as possible. And I think that's all, if anyone else doesn't have any other question. So thank you very much, Jose Luis, for being here, and thank you to all the attendees for their time, and see you in the next one.
Thank you so much, Estrella.